Okay, so today we are going to be going over physical and chemical changes, and you've learned about this in previous grades, so I kind of just want you to take the time and go to the next slide. And if you were actually in class, I would have you do a think, pair, share, which is where you think about it for 30 seconds, and then you pair with a partner next to you, and then you would share your ideas over the question. What comes to mind when you hear chemical and physical changes? And you would share that with the person closest to you. And so I'm going to give you a little bit of time just to kind of think about that and think of any examples of chemical or physical changes that you can come up with. Okay, and then we are going to watch this video, and it's going to elaborate over chemical and physical changes, and then we are going to go over it.
Vinegar, and today we'll explore the science behind chemical versus physical changes. Physical changes often happen when matter changes states. This solid spoon is made of a metal called gallium. Zoe, why don't you take the spoon and stir it into the very hot water?
When you put the spoon into the hot water, it causes it to melt.
Right? But the shiny liquid at the bottom is still the same metal. So it's not a new substance. And it's a physical change.
Correct. A chemical change is different. It forms entirely new substances. This gummy candy is made of sugar. Let's see what happens when we toss it into this tube of oxidizer. That's a chemical that provides a lot of oxygen to help things burn. Don't try this at home. Here we go. Now that's a chemical reaction. The gummy candy burned up, forming entirely new chemicals, like this carbon. Gummy candy?
Oh, no thanks.
I'm actually pretty full from that hot dog shake.
Yes, please. Hey, kids, if you want to watch this whole episode and more,
Okay, so after watching that video, one physical change that they went over was the geranium pretty much disappearing or melting to the bottom of the glass. And that is a physical change because it just changed the form. It didn't make a new substance, it's still geranium at the bottom. And that is very important to remember, that physical changes are changes that alter your size, the shape, the location, or the physical state of a substance, but not the chemical state. So some more examples of physical changes would be if you take a piece of paper and you crumble it and you throw it in the trash, it's a physical change of paper because you're not getting a new product from the paper. You can literally take the piece of paper out of the trash and unwrinkle it, and you still have a piece of paper. So another example is water boiling. Whenever you boil water, it transforms into vapor, but it is still water. So that's another example of a physical change. Some other forms of physical changes are cutting, tearing, shrinking, dissolving, molding, basically anything you can do not to get a new substance formed. And then chemical changes are the changes that alter the chemical makeup and the substance being changed. So an example of a chemical change would be burning wood, because once you burn the wood, you don't have any wood left, you only have ashes. So that's an example of a chemical change. And then we're going to go to the next slide, and if you were in class, you would be doing making a pumpkin experiment. And you'll note that says while we are creating the pumpkin, fill out the notes on the next slide. That slide looks like this, so you need to make sure that you have these notes filled out, but we are going to go ahead and watch the video, but you need to make sure that you keep these 3 questions in mind, because you do need to fill in your answers in these text boxes. So let's go watch the video really quick. And I will also link it, but I just want to make sure that you're getting the concept.
Teacher assistant from MSU, and today we're going to be doing a science experiment with creating a pumpkin, and then we are going to destroy it. So the first ingredient that you're going to need is baking soda, which is already in this box. Then we're going to add water to the baking soda. Then I'm going to add my orange soda because I want to make a pumpkin color. And now I want you to take the time to think, is me adding the orange soda a chemical or a physical change? And then you can pause the video and take some time to elaborate on that while I'm mixing this up.
Okay, so I'm going to explain it more in detail in the video, but think about me adding the soap. Is it a physical or a chemical change? And let's relate back to physical changes, or changes that alter the size, the shape, location, or physical state. Color is a physical state, so this is going to be a physical change.
But you should answer that it's a physical change because you're not getting a new substance, you are just changing the color to orange, since we're trying to make a pumpkin. So now I'm going to mold this into a pumpkin the best that I can, because it's being a little complicated. And while I'm doing this, think about changing the form changing to a pumpkin shape. Also think, is that a chemical change or a physical change?
Okay, so let's think about changing from the form that I have here, which is just a big mess, into the shape of a pumpkin. Would it be chemical or would it be physical? And you want to go, think that it's a physical change because it's just altering the shape of the baking soda, water, and soap.
And you can pause the video, but you should say that it's a physical change because it is changing the shape from blob, basically, to a pumpkin that I'm trying to make. Okay, so once we do that, I'm going to take these off because they are a mess. And now this is a cute little pipe cleaner, and it's going to be your pumpkin stick. So you can see my pumpkin. That's not perfect, but it'll work for today. And then I am going to destroy the pumpkin. And I'm going to destroy the pumpkin by removing the stem real fast and pouring vinegar over it. So whenever I pour the vinegar, I want you to think, what's going to happen? So I'm going to pour a little bit. You can see it destroying the pumpkin. It's almost about to overflow. Now, think about these little bubbles. What is happening here? And you should answer that there's carbon dioxide forming. That's why it's being carbonated. There's little bubbles. CO2 is forming from the vinegar and the baking soda reacting. And that will be a chemical change for this experiment. It's a chemical change because I can't go back in there and get my water out, I can't get my soap out, I can't get my baking soda out. It's definitely a new substance, and there is no going back. So that concludes our experiment. I'm going to clean up, and I will see you next time.
Okay, so after watching that video, you should be able to answer these questions. Number one, what happened after I added the water to the baking soda and began mixing it? What did we shape the baking soda and water into? And what happened when I poured the vinegar on the pumpkin? All those questions are answered in the video. Okay, and for the exit ticket, what you're going to do is you're going to click on this Google Form link, and you are going to fill out the questions, and you're going to submit them because they will be taken up as a grade. And one other thing, that if you were in class, the next day you'd be going over digestive system, so I would hand you a piece of like Halloween candy, and I would ask you what the chemical changes of digesting the candy are, what the physical changes of digesting the candy are. Just an example, a physical change would be chewing, because you still have like a Reese's, but it's just in a different form. But you also need to understand that once you swallow the candy and it hits your stomach, it is going to be digested by bile, which is stomach acid. So once it hits the stomach acid, it is a chemical change because you cannot get your Reese's back after that. And the enzymes in the stomach acid alter the state of the Reese's. And that is all I have for y'all today. I hope y'all have a great day, and I will see you later.